Hi everyone, let's solve question number 47. Let fx equals to a naught plus a1 mod x plus a2 mod x square plus a3 mod x cube, where these are the constants, which of the following statement is correct. So basically we have to find out differentiability for this function. Okay. So we have fx equals to, I'll write it in a modified way, that would be a naught plus a1 mod x plus a2 x square only, because x square and mod x square is the same thing, plus a3 mod x cube. Okay. Now, if this function has to be derivable, every individual function has to be differentiable, right? So a naught is differentiable because it's a constant function. A1 mod x is not a differentiable function because mod x is having a sharp value over it, basically sharp corner at x equals to 0. We know that it's not a derivable function at x equals to 0. Now, a2 mod x square. This is a differentiable function at x equals to 0 because it's smooth over here, right? And a3 mod x cube. Now that's the tricky part over here. So we can write mod x cube as x cube and minus x cube for x greater than equals to 0 and x less than 0, right? This is my third function. Let's say this is hx. Okay. Now if you want to find out the value of h dash x, we'll be getting 3x square and minus 3x square for x and for x. Okay. But if you put x equals to 0 over here, basically if you want to find out the derivative at x equals to 0, we are getting 0 only for both h dash x plus and h dash x minus, we are getting 0 only. So the difference, it is also differentiable at x equals to 0. The only critical point over here is x equals to 0 because the modulus sign is over here. The remaining function at all the remaining points, this is going to be differentiable because there is no critical point. The only point of worry was x equals to 0. So this one is differentiable, this one is differentiable, this is not, and we had to find out only this one. Okay, and this is also differentiable at x equals to 0 because we have proved that. Now only this function is not differentiable. Now if this function has to be differentiable, if this function has to be differentiable, entire function has to be differentiable, a1 should be 0. Only in that case it would be differentiable entirely for even x equals to 0. So C is the correct answer.